Oh, sir, because
Why
the
it is
impedances are
impedance
positive here.
diagram or reactance diagram?
It's
If I
reactance
say
because
that it is
the
admittance
impedance
diagram,
values are positive.
yes, positive. Another, any
Sir,
other thing to identify beside that? Regarding source is
আমি
connected in,
পারি না, sir. Yes,
okay,
sir.
regarding source, try
Oh,
to,
yes, 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 sir.
source is connected in series, right?
Uh,
And that
yes, sir.
source is voltage source, that is the indication that you have the admittance or reactance diagram, whatever you want to say. So if this is
Yes,
the
sir.
reactance diagram, can you draw the equivalent admittance diagram from that? In your
Yes,
paper,
sir, we
try to
can.
write or draw the equivalent admittance diagram from that given reactance diagram. You have 5 minutes to draw the equivalent admittance diagram in your paper. Actually, when you want to switch, first of all, how many elements you have to determine? Can you identify how many elements you have to convert equivalent admittance?
Sir, 1, 2, 3, 4, 5, 6.
Okay, 6 elements. You have, I think 5 minutes is sufficient to complete the job, right?
But sir, we don't know the voltage value, sir. তাহলে current source এ কেমনে নিব, sir?
Actually, regarding that voltage value, you can consider that E or the unknown value or whatever you understand. Okay, that
Okay.
voltage source that does not have value, but you have the source. Like current source, you may assign the direction or flow, but without the magnitude. Because to draw the admittance diagram, it is not necessary to have the value. You can get the equivalent admittance diagram from the given information. If it is unknown voltage source, your current source will be also the unknown quantity, like the symbolic representation of it.
Sir, could you kindly move the diagram a bit higher, sir?
Higher,
মানে opposite of node 3, we cannot see what is the element.
node 3. Node 3 is there.
মানে sir, node 3 নিচে there is 0.08.
Right. Is it
Has, oh,
observable
that's
now?
true. Oh, thank you. Yes, yes.
Node 4, that is the node 4, the lowermost node.
Sir, on top of
Yes.
1 and node 2, sir, there are two sources, sir. Sir, on should I consider the other end of the source to be ground?
Right. Actually, that is the node 1, and the other end of the source, like there's
Yes,
this voltage source that is connected to ground. Okay.
yes,
And if it is ground, what should be current direction or voltage direction, you know, right? Based on
yes,
the source configuration. The number 1 node side will be positive and ground side will be negative. Sabrina, are you there?
Yes, sir. Assalamu
Have you
alaikum.
done the admittance diagram?
Yes, sir.
Okay, wait for 2 minutes so that you can show the result. You can cross check your result. C34. What's your progress? How many of you 6 element you have converted?
Assalamualaikum, sir. Yes, sir, I'm doing it.
Yes. Yes. Have you converted the admittance information from the given diagram?
Yes, sir, I have drawn them and now I'm putting the values.
Okay. Okay. Okay.
Sir, there are some single lines here, sir, which contains a particular reluctance or
Single line means which one? This one? Single line means what?
So sir, 0.4J, 0.2J,
0.4J, right.
0.2J. So
Actually,
does that mean that this is the impedance value of this single line?
Yes, impedance value of
But
the
no component, just the line.
actually the value is given here. It may be line, okay. It may be the equivalent information of the line. In terms of line, you may have also the impedance information, right? The line in impedance it might be
Yes, sir. Yes, sir.
between node
Yes,
1
sir.
and 2. You have the line connection, and line have also the impedance information. You might have some component like transformer or any types of device. Or line itself has also the reactance information or impedance information. So now I think the time is already over. So I think you have done the job or not. 314. Have
Yes,
you
sir.
completed six
Done,
six
sir.
months?
Yes, sir.
Okay.
Yes.
Let's check whether you have got this response or not. Or is there any difference? Whatever you have designed. Is it match your result?
Sir, my current
Yes, sir.
direction is opposite, sir. But other
Yes,
than
sir.
that, sir, everything
Current
is
direction, regarding current direction. Okay, fine. It was node 1, right? So node 1, if you have current direction in upward, it means current is flowing from positive to ground. But what is actually the regular scenario? It should be from negative to positive, right? For the source, current source. If you have positive voltage to current source conversion, which direction you want to
Oh,
assign
yes.
the
Oh,
current?
sorry. Yeah. Oh, yes, sir. Yes, sir. Yes, sir.
I've got the point. Okay. Saifa, have you got the same response?
Yes, the same, sir.
Okay. The current source is okay for you?
Yes, sir.
Okay, fine. So if this is the admittance diagram, one interesting fact to regarding the symbol or Y10, you can see Y10 here. That means between 1 and ground. Y12 is in between node 1 and node 2 in this way. They are mentioned. Okay. Y20 is between node 2 and ground. So if we just want to write or complete the nodal equation of those node, actually you have 1, 2, 3. Actually, how many nodes? 4, right? So based on those 4 nodes,
Yes, sir.
you have actually the symbolic notation like Y10, Y20, or Y13, Y23. Based on those notation, try to write the KCL equation. Have you got my point? Instead of value, try to write the KCL equation in terms of symbol or the notation. Okay.
Sir, can you repeat the question again?
Question is that you have to write KCL equation. Okay. KCL equation in terms of y, not in terms of the value or magnitude. Try to write KCL equation in terms of symbol or notation. Y10, Y13, Y12 like this. Okay. Y20, Y23 like this. Instead of the value, try to write the KCL equation in terms of its notation. You have to write four nodal equation. Voltage for that node 1 is V1, like the earlier case, V2, V3 as well as V4. Series 322. Please mute yourself if you are not asking any question. 18 series 322. You have to write four different nodal equation in terms of symbol or the y in terms of y, not in terms of its value. And you have four equation for 2 minutes is I think sufficient to write those four equations, if you can understand. What about node 1? You have how many branch attached to node 1? 1, 2, 3, 4, right? Node 1, you have to integrate four different parameter or four different elements.
Sir, 4 number নোডের ইকুয়েশনটা how will you write it, sir? The
For
equation
for number 4, node 4,
node, yes,
you
yes.
have the actually what is attached to that node?
So only one Y34.
Yes, Y34. So you have to write accordingly that Y34 is attached to two node, right?
Node
V3 and V4.
Yes, sir. Yes, sir. So Y34 into মানে into the কি বলে voltage equals to 0. That is my node 4.
Right, right.
Sir, could
Yes.
you check the chat box, please?
Okay. Let me check. You have sent some file. V1, V2, Y1, 2. 334. V13. You have written V13, right? V12.
Yes, sir.
V13. What does it mean by V13? You may write V1 or V3, not V13, right? That is not correct.
Oh,
You have,
sir, I meant that, sir, V1 থেকে V3 তে যে ভোল্টেজটা আছে ওটা
no,
মিন
no,
করছিলাম, স্যার।
that doesn't indicate that. That you have to write
মানে স্যার
V1.
V1 minus V3
Right,
স্যার।
right. V1 minus V3. You have to write it like that.
স্যার
You
ওটাকে তো
write,
স্যার আমরা শর্টকাটে এভাবে লিখতাম না যে VAB is equals to VA minus VB, ওভাবে করে
oh,
চিন্তা
আচ্ছা
করেছি
আচ্ছা
স্যার।
ওভাবে আচ্ছা বুঝছি কিন্তু you have to write
স্যার ওই যে
actually
একদম একদম বাচ্চা ক্লাসে যেটা
okay,
পড়ছিলাম
okay,
স্যার
right.
ওভাবে।
Actually you have to write in details, okay, for this case. Because we have
জি
to
স্যার, জি স্যার, জি স্যার, বুঝতে
we
পারছি।
have to split that in terms of V1, V2, V3, like, okay,
জি স্যার,
okay. And
জি স্যার, আর যদি লিখি তাহলে লাস্টে লিখে দিলে হবে
regarding
তো না
that
যে
node 1, there is actually current source, right? You have written 0. You have not include current source or something like that. Oh,
স্যার করছি স্যার, সেকেন্ডে স্যার
current
মাইনাস
source in,
I1।
okay. Current source in this direction. Current source actually you have to put in other side of the equation so that you can formulate the bus,
sir.
Y bus easily. All the current source in one side and the voltage and admittance information in other side. Okay. So let me.
স্যার আমি সেন্ড করলাম না স্যার, আমি খাতায় লিখে রেখেছি স্যার।
ঠিক আছে। If you write that in proper way, I will give the information actually just now. Okay. One interesting thing that you have to rearrange that equation in terms of the regular one. Okay. That means V1, V2, V3, V4, like rearrangement. Whatever you have written in KCL equation, try to rearrange that equation in terms of V1, V2, V3, V4. Okay. This is the generalized actually bus admittance matrix response, whatever you have derived or get. You can cross check the
Instead of
result.
I1 and
Yes, that
sir,
whatever it's
instead
not
of
mandatory.
I1 and I2 sir, I wrote it in terms of E1 and E2. It's like I took an imaginary voltage equals to E1 for I1 and
E1
E2
is
for
not
I2.
actually I1, right? E1 is voltage and I1 is current. So you cannot mix
Yes sir,
the
yes
voltage
sir.
and
I
current.
mean
E1, I1 is
yes sir.
responsible for.
I divided it sir.
Okay. This is actually
With that
Vy
data,
means
data,
I, right? If you multiply
Yes, sir.
admittance with voltage, it will be equals to I also. So it's nothing but actually current law, Kirchhoff's current law, KCL. So the right side
Yes.
should be equals to left side in terms of current, not voltage. So this will be the response if you have written correctly. Okay. And the nodal equation, when you generate that equation I1 in terms of capital Y11, here you can see Y10 in small y, right? But here it is Y11, that is the capital Y. And that capital Y11, if you can recall, this is nothing but the self admittance or driving point admittance. Okay. Y11 is self admittance or driving point admittance. So try to rearrange your nodal equation in terms of V1, V2, V3, V4 like this. Okay, V1, V2, V3, V4, and here it is given the coefficient of all the voltage, which is Y11 means self admittance or driving point admittance. Y12 will be mutual admittance, okay, mutual admittance or transfer admittance, mutual admittance or transfer admittance, Y12, this coefficient, Y, capital Y, this is not small y, small y is the regular admittance value, but capital Y is the actually summation or other information, it is the coefficient of voltage, okay. So the difference between small y and capital Y, have you got that? They are different. This Y11 is the result or resultant of coefficient of V1. So in this expression, you have how many V1? 1, 2, 3. So when you add all the three y, small y, you can have this capital Y, which is self-admittance, okay, or driving point admittance. So if we just want to compare this equation and the generalized nodal equation, can you equate this capital Y11 in terms of small y? Try to equate these two equations. First one with this generalized one and extract the self coefficient, self admittance matrix, which is the coefficient of V1, as well as what is the value of Y12, Y13 and Y14. Compare this equation, that means first equation and this equation. So what should be the coefficient value? What will be Y11? Right, 315 correct. So if you have written Y11, there might be one generalized, okay, write Y12. What is Y12? Write Y12 as well. Y11 is the self-admittance or driving point admittance. Y12 or Y13, Y14 are the mutual admittance or transfer admittance. Transfer admittance. Write Y12 as well. Suha, 315. What is Y12? The coefficient of V2.
Sir, I have sent you all the equivalent things.
Actually,
The Y11, Y12, Y13,
yes, actually,
Y14.
Y12 is not correct in terms of polarity because V2 has some polarity issue, right? V2, the coefficient of V2 will have some polarity or negative magnitude, right?
Yes, sir, there should be minus. I forgot the
Right,
minus.
right.
Sorry,
We
sir.
have to put minus and regarding, okay, fine. Y14 is not there. So, okay, C34, you have written correctly. Now, we want to observe the generalized format to consider that. This is the actual equivalent, sorry, equivalent set. When you extract the information comparing that generalized form, you can get like this, right? Y11, Y22, Y33, Y44, like this. After extraction, by comparing the generalized form. And Y12, those who have generated, it is minus Y12, small, right? So if we just generalize that equation, that expression, try to compare this one.
The question টা আরেকবার
This
করবেন
is
বুঝতে
the
পারিনি ঠিক।
generalized. Try to write these two formula in your paper. Okay. Y, capital Y, small I equals summation of j equals 0 and j equals not equals I up to n. Okay. Y, then small y I j. Write these two equations in your paper. One for self-admittance or driving point admittance, another one for mutual admittance or transfer admittance. This is the generalized equation. Okay. Have you written this equation in your paper?
Sir, I'm writing it.
Okay. When you complete the writing, try to inform. Okay. If you have completed that writing. 1 minute to write these two equations.
Done.
Okay.
Done,
If you
sir.
done the job, now these two equation explanation, the earlier part, that means what we have already generated. Try to cross check the equation with the given result. Now you can actually see what is going on there. We want to observe what is going on there. Consider the first equation or first expression y11. Okay. If you put I as 1, okay, I as 1, what will be capital Y? It will be Y11, right?
1 1.
Right. And what about the right hand side? It will be small y, as I is 1, it is okay. You have to start the summation from 0, right? Ij, this is Ij. So 1, 0, j is 0, starting from 0. So Yij is Y10. Then you cannot consider j equals I, right? That's why you don't have small y11 here. Okay. Second term is not present here because summation will be excluded from that in terms of j equals I. So if I is 1, you cannot consider y, small y, 1 1. Is it clear? T14?
Yes, sir.
Okay.
So
Then
small y 1 1 sir exist করে না মানে
it doesn't
1
exist,
1 এ তো
but
কোনো
if it exists, you cannot consider. Okay, that's the idea. If it exists, you cannot
Yes.
consider for the coefficient matrix. So then j is, sorry, I is 1, j is 2, because j 1 should not be considered, j will be 2, and j I1, j 3, right? And n will be what? N will be actually 4, right? N will be 4. Is it clear?
Yes, sir.
Yes, sir.
4. So you have to actually have there y14 as well, but y14 is actually 0. That's why if you write y, small y14, that will be cancelled. So
Sir,
this is
তাহলে এখানে
the
n হচ্ছে node
node number,
number of
right?
nodes.
Number of nodes n, and I is the considering node. Now consider this equation, second one or third one. Say for example, we have considered y33. Can you cross check the equation or justify that? If
Sir, it's justified, sir. It's okay.
yes, if it is 3, in that case only y small y33 is not there, right? because
Yes.
j should not be equals to I. Other are there. That is the self admittance or driving point admittance consideration, coefficient generation. Okay, and this is the capital Y. Remember that capital Y is the coefficient matrix, and small y is the matrix. That means admittance itself. So this is actually the summation of all the admittance matrix. Now we want to check this side, mutual admittance. Regarding mutual admittance, it might be Y12 or Y21, they are same. Okay, because these are the magnitude value. So it is the non-directional or non-polar device admittance. So you can consider Y12 equals Y21. And there you can see negative, right? Negative Y12 or Yij. If your I is 1 and j is 2. Likewise, these are the sets of all the admittance information in terms of transfer.
Is this applicable universally? It's like
Right.
নাকি
This
খালি
is the
particular
universal
maths এর জন্য এটা?
Yes, this is applicable
Okay.
for all the scenario. That's why that generalized equation is written. Okay, you can use that equation. Actually, when we solve the complex problem, in that case, we might not use these types of distributed equation. In only the generalized format will be there to represent that coefficient. Okay, when we solve the large problem or multiple source or multiple network, in that case we might use only the generalized form, the summation form. Okay, but we know how to generate that generalized form, right? How we can get that or get there from the basic equation. And regarding this Y14 or Y41, as is already mentioned, we don't have any connection between node 1 and node 4, right? That's why you have the coefficient of 0. Okay. So this is the thing regarding the admittance, bus admittance matrix idea. So when we have bus admittance matrix in our hand, as I have already mentioned, the current should be in one side and admittance Y and voltage should be in other side. And in this way, that means the matrix formidable. This is the matrix orientation, right? So when you have these types of matrix block, this matrix will be known as Y bus. Okay, Y bus. The coefficient of,
Sir?
yes.
আমরা যে কেসিএল সলভ করলাম ওখানে নোট 3 আর নোট 4 কিংবা অন্য কোথাও i3 i4 পাইনি, কিন্তু এখানে তো i1 i2 অনেকগুলো i দেখা যাচ্ছে। তাহলে যতগুলা নোড ইকুয়েশন অতগুলা কারেন্টস কি পাওয়ার কথা, না হলে আমার কারেন্টের বাসটা কমপ্লিট হবে?
Regarding that current bus, that means this bus, right? This line. If you don't have the presence of current source, in that case you can put 0. Okay. If you have 4 current source or attached to 4 node, you can put all those. If it is not there, say for example, out of 4 you have only current source attached to node 2 only, you can put that value and the remaining will be 0. Put the 0. Okay, fill up the other column with 0 information if it is not there. Okay. I think you have got it.
এই বাস ম্যাট্রিক্স ফর্ম, এটার মেইন পারপাসটা হচ্ছে কি আমি কারেন্টস বের করব, এটার সাহায্য কোন স্যার?
No, bus matrix is actually for this Y bus. Our target is to generate this matrix. This Y bus is our objective. Okay, and to generate that Y bus, this is not actually the regular admittance, right? Just now you have seen this capital Y1 is the driving point admittance or the summation of all the admittance in that Y11. It is not individual admittance, right? It is actually the multiple admittance attached to that. So when you have this multiple admittance here, these diagonal matrices are the self-driving matrix, Y11 or Y22, YII or YNN. As we have 4 node, we can have 4 by 4 matrix of Y. Okay. And regarding that 4 by 4 matrix, this is the ultimate result of that Y bus matrix, whatever you have generated or achieved. Okay. You can compare that
Yes, sir.
in terms of the earlier notation of admittance diagram, whether this match or not. You have the admittance diagram, right, in your hand. And that admittance diagram you can cross check or you can justify whether you can get that or not based on coefficient matrix. Here you have the admittance diagram and you have the notation. If it is Y11, the position of this one is nothing but Y11, right? This Y11 is the summation of how many components? 1, 2, 3, 4, right?
3.
4, but 1 is not present because Y14 is not there. If you have
Yes, sir.
any connection between this 1 and 4, like any other line connection or any admittance interconnection between this 1 and 4, you have to consider that as well. Okay. For this case, as there is not any connection between node 1 and 4, you have 0 there. Okay. Otherwise, you have to consider that also.
I get it, sir.
So this is the admittance diagram idea. So I think you have got the idea clear that what is the generalized admittance matrix coefficient, how we can generate the regular Y bus from the reactance diagram. We have started from reactance diagram, right? Or admittance diagram, whatever you want to say. The admittance or reactance diagram, modified admittance diagram, you can say. Reactance diagram, then we have generated admittance diagram. Then from that admittance diagram, we have extracted the nodal equation. Nodal equation, from that nodal equation, we have rearranged that nodal equation in terms of coefficient matrix Y, capital Y, right? Capital Y, when we have all the capital Y in our hand, we can extract that capital Y to generate Y bus. That's the ultimate target. Okay. This Y bus is actually required for our other steps or other jobs or next step purpose. Okay. So if you have been given some diagram in terms of reactance diagram, or sometimes you may be given in terms of single line diagram, right? Up to now, what we have learned, if it is given in single line diagram, can you form or generate the Y bus from there after so many steps? Can we do that? If you have been given instead of reactance diagram, I have given, say for example, the single line diagram. Can you extract Y bus from there? 314?
Sir. Yes, sir. Yes, sir. Yes, sir. We can, sir, because
Okay. What
because
will
with
be
the
the
single
step?
line,
First step?
the impedance দেওয়া থাকবে, sir. Yes.
Impedance will be given, or it may be no, it may not given the impedance, the other information like voltage or other information, capacity,
Yes, sir.
right? Then you have to generate per
Yes.
unit diagram from that. From single line
Exactly, sir.
diagram
That's the first thing.
to per unit
Yes, sir.
diagram. Then per unit diagram, you
Yes.
can have the information of all the per unit so that you can generate impedance diagram by yourself, right? First step, the
Yes, sir.
impedance diagram drawing. When you complete the impedance diagram, then you can modify or that for reactance diagram, right? Then after reactance diagram,
Yes.
we can generate the equivalent admittance diagram. Then from that admittance diagram, the nodal equation, rearrangement of the equation, then the Y bus extraction or the coefficient matrix will give you your desired Y bus. Okay, that's the objective or that's your target.
Yes.
This is actually the starting point. Okay, up to now, that means this Y bus is the very starting point of this course. These all the steps is actually the starting point. We have not started any critical or complex problem up to now. Just the foundation or the what is required to address the complex problem. Okay, these are the very basic. That means you have to actually have this starting point of Y bus. If you have been given single line diagram or if it is in a descriptive information of the problem, first step is to generate Y bus. After so many calculation or after so many steps, this is the starting point to address the next layer of the job. Okay, this Y bus is the foundation of this course. The other things are actually the review topics or whatever you have learned earlier or in other course like circuit course or three-phase circuit or transformer idea. Those are the background. Okay, but this Y bus is our actually the starting point of this course based on per unit concept.
I have a small question, sir. In tomorrow's quiz that is going to take place, sir. The questions that will be given, sir, it's like the prerequisite to the Y bus. It's like একদম first যা যা শিখেছিলাম
It's
একদম মানে
not
বাবু
Y
জিনিস
bus.
পড়ে,
It's
এই
not Y
chapter
bus. Y bus is not there for first
not.
quiz. Okay.
Yes.
But I have just
Yes.
mentioned that Y bus is the target. Actually, this is the target or starting topic of this course. Per unit and Y bus. These are the very basic or starting topic. So Y bus will not be the quiz topic of the tomorrow's quiz. Okay. And there will not be the actually regular class tomorrow, only the class test on 150 at 150. Okay, 150 you have the class test for all the section. So try to be there before 5 minutes early. 145 try to be there. So now we want to move for other topics or other issues. The bus admittance matrix, the topics just now we have discussed. The bus admittance matrix, okay, fine. Now, another topics we want to start. This is the nonlinear equation solution. Okay, new topics. Okay, new topics now. New topics considering nonlinear equation, algebraic equation solution. Have you ever used or have you got the idea of nonlinear equation? Which equation you can say that this is the nonlinear equation? Can you differentiate between linear equation and nonlinear equation?
Yes, sir. One that is proportional to between proportional relationship between quantities, sir. That is linear. Sir.
Linear. Can you
And non-linear
give
is
some
if it is a
example?
square time increase.
Okay. Can you give some
I
example?
mathematically parbo, sir.
Of,
yes,
not
sir.
in,
Y equals to mx.
Okay. If
Yes,
I
sir, that's the
say
relation.
the Ohm's law, is it linear or non-linear?
Yes, sir, it is linear, sir. It is linear. Sir.
Right. So you can relate, right? In terms of electrical
Yes.
engineering, the linearity. Okay, Ohm's
Yes.
law, if it is
Yes,
Ohm's
yes.
law, it is linear. But can you have the idea of non-linear equation? Which equation is non-linear? Like
exponential.
Okay, exponential equation may be non-linear. You might have some polynomial equation, right? that is the non-linear. You
Y
might
equals to
have,
x squared.
right, x square. You might have uh, uh, what I can say, the power equation, right? Power equation will be non-linear because of the combination
Exactly,
of
v
voltage
square
and
by
current,
r.
right? If you have instantaneous voltage and instantaneous current, the power equation will be non-linear. So likewise, the system, that means power in electrical course, you might have some non-linear equation as well. Ohm's law is linear, but beside that, some equation you might face which are the non-linear type. So when you have this non-linear equation in your hand, how can you address the solution or root extraction of that? That's the topic. Okay. That can be solved based on different approach like Gauss-Seidel method or Newton-Raphson method. So these are the common method to determine the solution of the nonlinear equation. Okay. And another thing, this is iterative method or iterative solution approach. So iterative solution means you cannot get the result in direct solution. Like if it is linear equation, y equals mx or Ohm's law, if you just solve that equation, it will give you the result in single iteration, right? That means one solution or one step is sufficient to generate the result. But for this case, it requires multiple layer or multiple step to get the outcome or result. Okay. So have you ever heard this terminology, Gauss-Seidel or Newton-Raphson in math course or any other course earlier?
আধা আধা শুনেছি স্যার, গাউস শুনেছি, নিউটন
Gauss,
শুনেছি, কোয়াসি শুনেছি, কিন্তু
Quasi
এটার সাথে অন্য টার্মগুলো শুনিনি।
আচ্ছা, Gauss-Seidel এগুলো শুনেনি। Gauss, আচ্ছা, okay, fine. Actually, Gauss-Seidel method, as you have already know or we have already mentioned that polynomial equation might be one category of nonlinear algebraic equation, right? That means that is the nth order of equation. It might be any order. It might be square, it might be cube, it might be to the power 4 or to the power n. Okay. So if it is quadratic equation or if it is polynomial equation, in that case that is non-linear, right? So if you have been given some function, that is the function of x in terms of 0, so any equation can be represented or any linear or non-linear equation can be represented in terms of function, right? That means if you put some value of x, you can get the y corresponding y. Okay. So if your fx or y value is 0, what does it mean? Can you interpret that? If fx is 0, what does it indicate?
So it's a homogeneous equation.
In simple way, if you just fx means what? Y, right? Fx is
Y,
nothing
sir,
but
yes.
y. If it y equals 0, what does it imply? If you just put
Parallel.
y is 0,
So solution, sir, we are finding solution.
right, solution. So y equals 0 is solution, and it is actually nothing but the point in x-axis, right? Y equals 0 as the
Yes, sir, point.
point in x-axis. So it is the value in x-axis. So we have actually, if you have multiple solution, if you have, say for example, third order equation, right? How many solution do you have?
Yes, sir.
If it is x to the power
3,
3, you should have 3 solutions,
3
right?
solution.
Right. Three intersection points should be there, or 3 solution for that, maxima, minima. Okay. So if you have been there, if we have this type of equation, that above function can be rearranged like that. That means x can be g of x. Okay. The g means actually Gauss-Seidel g. Okay. We want to get the solution in terms of Gauss-Seidel. So these are the mathematical idea. Actually, to get that mathematics or the symbolic notation, it will be easier for you to understand the topic if we just solve any problem, so that you can get the idea clear what you have to do or what is necessary to address uh, Gauss-Seidel approach to solve any nonlinear algebraic equation. Say for example, this is the equation given. This is the polynomial equation, right? X cube minus 6x square plus 9x minus 4, right? This is nothing but, is it linear or non-linear?
Non-linear.
Non-linear. Actually, why it is non-linear? Because we have
Cubic, sir. It's a cubic
cube,
equation.
right? Cube or polynomial expression, right? Polynomial order. So if it is cube or x square or something like that, it is non-linear. So if you have non-linear equation, can you determine the solution of that? By observation, what should be the solution or what will be the intersection of x-axis? That is actually fx equals 0, right? Fx equals 0 means that will be the root or solution. So if you are asked to determine the root, what you have to put fx equals 0. So that will be give you the solution of that nonlinear equation. And can you find the solution of that?
Yes, sir.
Yes, sir.
How can you determine the solution?
So we can use it.
Sir, that is the first thing I would have said, or trial and error, sir.
Trial and error. Actually, you can in mathematics or in algebra, you might generate some ideas, right? For that
Roots,
case,
sir, roots.
roots, right?
একটা রুট বের করে স্যার তারপরে স্যার ডাবল লাইন মেথড দিয়ে করা যেত স্যার এটা বাবু ম্যাথস
Yes, actually the idea. So how to address that nonlinear solution, nonlinear equation root calculation? First step, you have to rearrange the given nonlinear equation in terms of x.
মেক
Okay, just take x in one side and all the information in other side. Write that equation in that way. Rearrange that equation.
তার মানে স্যার 9x টাকে একদিকে রেখে অন্য সবগুলোকে আরেকদিকে
Right. Actually, x, that means you have to subtract or divide that other side by 9. Okay, only x. So the coefficient of x is 9,
বুঝতে পেরেছি
but it should be free. That means coefficient will be 1 only. Divide both sides by 9. Rearrange that equation of x in one side and all the information in other side. And for these types of problem, there you have some initial condition. It will be already given to the system. What will you have to consider? So is it okay? The x information, only x in one side and all the information in other side. Is it okay?
yes yes
When you extract that x, that will be gx. Gx means Gauss-Seidel equivalent of the nonlinear equation. Okay. G means Gauss-Seidel equivalent. This is the Gauss-Seidel equivalent of the given nonlinear equation. Now, another step or the second step, you have to put initial condition or put x as 2. Initial condition of that equation x as 2. Okay.
so where is it given sir
It will be given initial condition for the system. it will be given put x equals 2. What will be gx? If g2, what is the value of this?
Sir, 1 minute. Sir, 20 by 9.
Okay, 20 by 9. If you put g2, right? So 20 by 9, try to find the fraction. So that 20 by 9, what is the equivalent? 20 by 9.
2.22.
Okay, 2.22. Okay, fine. This is 2 is the initial value. So you have got 2.22, right? Then put G 2.22. What will be the value?
হ্যাঁ স্যার বুঝতে পেরেছি স্যার হ্যাঁ হ্যাঁ হ্যাঁ
Okay. When you got the answer, put that answer again to that equation.
ইয়েস স্যার তারপরে এটা স্যার কনভার্জ করবে একটা ভ্যালুর দিকে রাইট স্যার
You have the converge result, and when you have got the same result, input as output, then you can stop
Twice.
the job. Okay, try to do that job. After how many steps you have got the result, or how many iteration you have response like that. When you reach
Sir, I didn't understand the last part.
actually, have you put GS2, the initial value?
Yes, sir.
What is your result?
Yes, sir.
What is your result?
2.22.
Okay, 2.22. Put that result again to the system. Feed that result to the system once again. Okay. Now what you have to determine G 2.22. What is the value? Okay. In this way, you have to do the job more. But that means you have to repeat the process until you have got the result. That means same as the input. What you have given, you have got the same result. Then you can stop
Yes,
the
sir.
journey. Okay.
স্যার তার মানে প্রসেসটা এমন যে আমি
We
ফার্স্টে
have
এক ভ্যালু দিচ্ছি পরে যেটা আমি
রেজাল্টটাকে আবার সিস্টেমে ফিট করাতে হবে।
হ্যাঁ
Then
হ্যাঁ হ্যাঁ মানে ওই রাইট সাইডের ইকুয়েশন gx এ
হ্যাঁ,
আবার ওটাকে আমি
আবার ওটাতে বসাবো ওই রেজাল্টটা বসানোর পরে you have to do the job repeatedly until and
যতক্ষণ পর্যন্ত
unless
আমার রেজাল্টটা x এর ভ্যালু সমান আসে না
that means same as input. That means whatever you have given, say for example you have put G 2.22 and the result is also 2.22, you can stop. Otherwise you have to repeat. Okay.
জি স্যার আপনি 2 থেকে স্টার্ট করেছেন আমি যদি 1 থেকে স্টার্ট করি ওটা কি সমস্যা হবে নাকি অলওয়েজ 2 থেকে স্টার্ট করব
Actually you can start from any point. Actually it's better to converge. It has the convergence around 2. That's why for that equation the initial condition will be given to you. Okay. If it is not given, in that case you might start from your idea, or you might start from
So it does not converge around 2 sir.
Okay, then it might be another point. Okay, try to put that value. You can start anywhere. It might be
It converges
10.
around 4 sir আমার cases.
Okay, okay. If it
Yes.
is 4, okay. How many after how many layer or how many iteration?
Sir, আমি 7th লেয়ারের পরে পেয়েছি তারপর 8 এ গিয়ে পুরো শিওর হয়ে গেছি
আচ্ছা আচ্ছা ঠিক আছে that means after 7 iteration you can reach your destination.
Yes sir, and 8 এ conclude করি স্যার
হ্যাঁ ঠিক আছে. So your result will be that means same as input, the given response. Actually you can start actually
এটা একটা ইজি নিয়ম আছে স্যার
হ্যাঁ yes কি
স্যার আমরা একটা কাজ করতে পারি না স্যার মনে করেন আমরা 0 থেকে মনে করেন যে মেইন ফাংশন f of x দেওয়া আছে ওটার মধ্যে আমরা 0 থেকে কয়েকটা ভ্যালু বসাই তারপর আমরা দেখতে পারবো স্যার x এর দুটো ভ্যালুর জন্য f of x এর সাইন চেঞ্জ হয় স্যার তারপরে ওই দুটোর একটা এভারেজ ভ্যালু দিয়ে শুরু করলে স্যার এটা তাড়াতাড়ি হবে স্যার এটা
okay that is another method,
আমি সামনে সামনে আপনাকে এটা ভালো বুঝাতে পারবো
method. Okay, that is another method
Yes,
to
sir, yes, sir, yes.
determine the solution of nonlinear equation, and that method is known as I think bisection method, or if I can recall, that is another way.
So I don't know the term sir but it
Bisection
আরেকটা
method
method
for
টাই হবে
iterative solution, right? That was another topic or another idea, or how to find the nonlinear equation. Actually this course you have two methodology to understand. Okay, that is another way you
Yes.
can find. For this
Okay.
case, this time you have to know this method, how you can address using this methodology also. Okay. You have lots of method to determine the nonlinear equation solution, but we will focus on Gauss-Seidel and Newton-Raphson for this course. Okay.
আমার দুটো ছোট ছোট কনফিউশন আছে স্যার। একটা কনফিউশন হচ্ছে স্যার এই যে টুটা শুরু করলাম স্যার, এটা তো আপনি আমাকে বলে দিয়েছেন, বাট এখানে তো বলা ছিল না।
It can be also 1 or it can be also 10. Okay, you can start from anywhere, but based on the actually data, it might converge after 7 or after 10 or after 100. You might have the convergence issue later or faster. That's the idea. Okay, but you might get the result in some way that it must converge. It might be 2, it might be 1,
And
it
sir,
might be any value. Okay.
Yes, and sir, here it says that there are two roots, sir, 1 and 4, where 1 is repeated, sir. কিন্তু স্যার আমরা তো এই প্রসেসে জাস্ট একটা রুট বের করতে স্যার, আরেকটা তো পারবো না।
Actually, for this methodology, it's already mentioned in the question that you have to identify only one. Okay, you might have lots of roots for polynomial equation. You might have multiple roots, but you have asked to generate only one root.
বুঝতে পারি।
So what about the other guys? Have you generated or get the result that is similar to your input, Saifa C34?
Yes, sir. It's 3.9999.
Okay, put
It's
that
in my
3.99 once again.
ninth
Okay, put that value once again.
iteration.
Okay, put that value once again so that you can get the result. In a later iteration, you might get the integer value or full response. So that is the approach, okay, regarding the Gauss-Seidel method to generate iterative solution for nonlinear equation. So first iteration 2.22, it's okay. Second iteration 2.51, right? Third iteration it will be 2.89 if you have got that. 3.999, okay, that is for 1, 2, 3, 4, 5, 6, 7. 7 iteration you can get that, but 8 iteration you can generate the ultimate result. Okay. So this is the methodology to generate iterative solution for nonlinear equation using Gauss-Seidel method. Okay. This is the graphical representation of that approach. Like when you put, what is our starting point? 2, right? 2, when you put x as 2, what we have got? 2.22, right? For first iteration. For first iteration, what is the value? 2.22. So 2 and 2.22 will be there, right? This is x is, and this is the gx. Gx is that means the Gauss-Seidel equivalent nonlinear equation, Gauss-Seidel gx. So when you have 2.22, when you have 2.22, it might be 2.51, right? So this is the staircase graphical representation of the result. When you put 4, you have get y or gx as also 4, right? When you put the 4 in that equation, what is your result? It should be 4. So in this way, these are the envelope of the Gauss-Seidel stair. Okay.
So should we know this graphical representation?
Actually, this is not no. You have to put all the result, what you have calculated in graph paper to generate or draw that. Okay. This is nothing but the drawing of your information.
Okay.
This is the value, starting value, first node. second point, third point, fourth point, likewise. Okay, and the envelope will give you the ultimate result. Or this is the nonlinear equation envelope. Okay. So sometimes you are asked to generate the graphical illustration of that problem after solution. Graphical illustration of Gauss-Seidel method. Okay. Last but not least, you might have acceleration factor attached to Gauss-Seidel method. Okay, this is the acceleration factor issue. Initially, you have not considered the acceleration factor alpha. Okay, but now to converge the problem or solution, you might have acceleration factor as well. If it is 1.25, that means 25% acceleration factor for the circuit. And how to address that accelerating factor issue? Earlier case, what it was? You have put 2 and got the result as 2.22, right? Do you get my point? For regular Gauss-Seidel,
Yes, sir.
Yes, sir.
when you have put 2 as x, you have got 2.22 for first iteration. Regular Gauss-Seidel you can reuse, or result can be reused for next feed. But for acceleration factor scenario, you cannot put 2.22 directly. You have to adjust that 2.22 in terms of acceleration factor. Okay, 2 is the initial value, 2.22 is the result, this is the difference. Okay, difference, and this is the multiplying factor in terms of acceleration factor. This acceleration factor consideration is 2.27. You have to put this 2.27 in next iteration instead of 2.22. Have you got the point? That is the difference.
এটা করলে কি আমার স্টেপস কয়েকটা কমে যাবে এরকম
It
কিছু?
will reduce the convergence, or it will get the result earlier. Okay.
Yes, sir.
That's why this convergence or accelerating factor consideration might be there sometimes. If it is given, you have to think like that. Okay. So you can try considering that acceleration factor. Okay. What will be the next iteration? Put that value 2.27. Second iteration, this is the first iteration result. Put that information for second iteration 2.27. Okay. In regular case, we have to put 2.22, but when you consider acceleration factor 1.25, you have to put 2.27 in the Gauss-Seidel equation. What you have got when you put 2.27? What is the response here? T34. Have you got the result when you put 2.27?
2.59 probably, sir.
2.59.
স্যার আমি করতেছি।
2.59. If it is 2.59, then 2.59 and 2.27 will be considered for acceleration factor adjustment. Okay. For earlier
তারপর
case,
নেক্সটটা কিভাবে করব স্যার? x2
x2 will be like that, 2.59 and 2.27, whatever you have considered, right? 2.27.
Yes.
This is the 2.27. This is the value. If it is regular, you can put that value for next iteration. But now you have to add the acceleration factor multiplied by the difference. Okay. Difference of that result of that iteration layer, 2.59 and 2.27 difference. This difference multiplied by acceleration factor, which you have to put for next iteration. Okay. 2.66 you have to put for third iteration. So likewise, try to do that job, the acceleration factor in your paper, and try to solve that whether you have got the convergence earlier or not. Try to check that.
স্যার
Okay,
এই স্টেপটা তো স্যার আরো মানে বেশি টাইম কনজিউমিং স্যার।
time consuming, but iteration step will be lesser. Say for example, you have to get the result 10 step, right? Now it is 5 step or 5.
Yes sir, yes sir, yes sir.
That's the idea, right? Though the calculation procedure is something complex, but the iterative approach or iteration layer will be reduced. So try to do that job in your paper, considering that acceleration factor. You can generate the result, I think. Have you got the idea of Gauss-Seidel solution for iterative method for nonlinear equation?
Yes,
So
sir.
answer comes in sir 7 steps sir this time.
Okay, might be one step lesser, or sometimes it may be faster. And regarding that acceleration factor, it might be mentioned. Okay, it is 1.25 for this case. It might be 1.4. It might be 1.5. Okay. So it will be given in the system or information. So thank you all for attending today's session. If you don't have any question, we can conclude today's session. Thank you all. Okay.
Assalamu alaikum sir.
Wa alaikum assalam wa rahmatullah.